So welcome to the session on Terra for data analysis. So this is just a quick high-level lecture to contextualize some of the hands-on exercises that we'll be doing directly afterwards. So feel free to post any questions in the Slack. I'll start by actually responding to one of the questions that I noticed in the Slack. Someone asked about the difference between Terra and Gen 3. And so for this lecture, I'll start by explaining that Terra is the analysis platform, whereas Gen 3 is more like the structured data set. So a lot of the hands-on demonstrations that you're going to be seeing now are about getting you accustomed to using the Terra interface. So that being said, this short lecture that we're going to do right now is really about tying the features on Terra to the different types of cloud-based advantages that it's built around. So you'll understand what types of analysis you can do and why it's preferable to do them on something like Terra. So we'll talk a little bit about how the interactive analysis aspect works, specifically Jupyter Notebooks, which is what most of my hands-on demonstration will be about. And we'll touch on RStudio, although that is a part of hands-on demonstration at the end of the day. And we'll also touch on how you can use batch analysis, which you actually just heard a very detailed explanation of the workflow description language and how to submit WDL scripts to Cromwell. And you'll see an example of how to do this in the hands-on session. So I'll start by just giving this very high-level explanation, reiterating the two main advantages of working in the cloud in general. So as we mentioned earlier, working in the cloud is true data sharing rather than data copying. So in the past, data sharing has always actually been data copying, which is very inefficient in terms of storage, whereas having true data sharing is much more efficient in terms of storage because you only have to have one location for all of the data. But it's also very useful for versioning, which is something I think that's come up several times throughout these lectures. Particularly, Louise talked a lot about how different versions can be tracked in DocStore, and dependencies are depend very strongly on having the correct versions, and having a true data sharing in a centralized location is one of the ways to make this a very robust process. In addition to that, cloud computing offers this amazing advantage of computational elasticity. And I'll just say very quickly, the whole point here is that somebody else owns a whole lot of computers, and by creating this cloud paradigm as an agreement with the owners of the computational resources, they charge us only for whatever computational resources we are requisitioning at any given time. And so this is very cost efficient. One of the reasons being that the amount of computation that you'll use actually varies with a lot of different variables. For example, the time of year. So you'll find that there's much more heavy use of computational resources when you are preparing to go to a conference, for example, and you want to make sure that everything that you're going to be presenting is still working and that all of your versions are up to date. You'll find you're using a lot more computational resources. And rather than having to pay for that infrastructure up front, you can sign up for a cloud-based solution like this one. And so the advantage is really that you can requisition whatever amount of computational resources you want at the touch of a button. So now that we've talked a little bit about how the advantages are leveraged, let me show you some specific examples of how this is implemented in Terra. The main demonstration that you'll be seeing of the implementation will be in Jupyter Notebooks. So one of the things that you can do is create what we call a cluster or a virtual machine in the cloud. And when you do that, you can then run a Jupyter Notebook from that machine. Can I ask very quickly for the participants by show of hands to say how familiar they are with working with Jupyter notebooks. So raise your hand if you've ever opened a Jupyter notebook. I'll just give a couple seconds for people to respond. Okay, great. So it looks like quite a few people are familiar with the idea. Probably you've run Jupyter notebooks either off of your own machine or off of some other cloud-based application. So I'll explain a little bit about how Jupyter notebooks work on Terra. So when you launch a Jupyter notebook, what you do is create a virtual machine. And when you create that virtual machine, its memory persists until you click to delete or replace that runtime environment. And you'll see exactly what I'm talking about when we are actually in the interface during the hands-on demonstration. But here on this screen, you can see in the top right, there's the notebook runtime button. And that's where you control what your virtual machine is doing, whether it's running or whether it's paused or what parameters you've requisitioned. In addition to that, we have a few different modes, computational modes inside of the Jupyter notebook that we've implemented in the Terra version. And so I want to quickly explain the difference between working in edit mode and in playground mode. And you'll see this again during the hands-on demonstration. So don't worry if it sounds a little strange. But there are two different modes when you open a notebook. Actually, I should say there are three because there is a read-only preview version, which doesn't enable you to interact with the code in any way other than to look at it. There is an editable mode in which you are able to interact with and run the code. And when you interact with that code, when you run it, the results from that code are saved permanently to your virtual machine. In playground mode, on the other hand, when you run code, the code is parsed and completed, but the results won't necessarily be automatically saved. And if you're editing the code in your Jupyter notebook in playground mode, those changes won't be saved. And the reason we do this is so that multiple people can work in the same notebook within the same workspace at the same time without overwriting one another. So when you open a notebook, you'll see that you can open it in edit mode or in playground mode. If you were to open that notebook in edit mode and then share your same workspace with another coworker, they would still be able to open that notebook, but they would no longer be able to do so in edit mode. They would have to use playground mode. And I'll show you again when we get to that point. In addition to being able to set things to edit mode and playground mode, there's also a huge variety of configuration options when you are setting up your runtime environment. And so you'll see this window pop up when you press that runtime environment button at the top right corner. And again, you'll see all of this in detail in a moment. We have a whole lot of preset environments as well as a lot of options for customizing your computational environment. And we'll show you some of the different options when we get inside of the tour and hopefully explain some of the differences between those options. One thing that I'll point out about how our Jupyter notebooks are implemented is that they run off of Docker containers, similarly to how Louise described them. You can find the base images. As Louise mentioned, an image is more or less an interchangeable term with a Docker container. The image you can think of as the version, the specific snapshot version of a particular container. And so here we have on our Git the list of the different base containers that you can use for Terra-based Jupyter notebooks. I'll point out, for example, there is a base image for bioconductor. You can see at the bottom of this list under Terra base images. There's one base image that is specifically for the bioconductor package. So if you were to open a notebook with this environment, you would immediately be able to use the default bioconductor version. I'll quickly ask by show of hands also, how many people are familiar with bioconductor? Wow, lots of people. So I guess I won't go too deeply into what bioconductor is. It's a very popular software package based mostly on R, I think partly on things that aren't R also, for comprehending genomic data produced in molecular biology labs. And you're going to be seeing how it's implemented inside of a Jupyter environment. And so that's pretty much everything that you need to understand about how Jupyter notebooks are implemented at a high level. And you'll see all of that again in detail in a moment. On the other hand, there is batch processing. So we have two forms of analysis really on Terra. There's interactive analysis with Jupyter notebooks, and there is what we call batch processing. You just heard a very detailed explanation of how the workflow description language works. And in Terra, you can actually submit WDL scripts to our cloud-based Cromwell execution engine, and you'll see how to do that as well during the demonstration. So with that all being said, I'm going to switch over to my browser and go to the anvil.terra.bio homepage. I'll take a pause for maybe 2 or 3 minutes to open the floor up for any questions, and then we'll get started right away.